Hello, this is the luckiest maths teacher in the world, and today you're in for a real treat. You're going to learn about distance versus time graphs. Now, they're just like those linear graphs that we're doing last lesson, just with a specific purpose. Now, important to note that by convention, distance is along the y-axis, which is the vertical axis, and time along the x-axis. So remember, vertical goes up and down, y-axis always goes up and down, where distance is. And time, x-axis, is always going left to right. So there's two things that you need to know how to do for distance and time graphs. Number one, you have to be able to interpret a graph that you're given. And number two, draw your own graphs. Okay, so I'll give an example of each of those questions. I'm sure you're really intrigued. Let's get to it. So first off, I'll give you a graph and we'll look at some questions related to it. So here's an example of a distance-time graph, and as I said, you'll notice that distance over here is on the vertical axis and time is on the horizontal axis down here. So we'll now do a few of the type of questions that you'll need to know how to do. So the first question I'm going to give you is to ask, how long did it take for this person to travel 40 metres? So whenever you get a question that says how long or at what time, it's asking you for the time, or in other words, the corresponding x value. So let's look at our graph. So what's actually happened in this journey is that this person has started travelling here, then they've had a rest, then they've kept on travelling, and they've ended up travelling 40 metres one way, and then this slopey line here means that they've actually come back. So they travelled 40 metres to wherever, and then they went back to where they started. Okay, so to answer this question isn't that hard, because we can see that where we've travelled 40 metres, the corresponding x value, if we go down here, is 60. Now it says here time is in seconds, okay? So nice and easy. The answer is, how long did it take to travel 40 metres? It took 60, and you can just write S for seconds. All right, cool. Let's do another question. Okay, next question. So looking at the exact same graph, from the graph, can we tell when the person had a rest? So to answer this, you just have to think, what does a rest actually mean? Well, a rest means they're not travelling. They're not increasing their distance, even though time is increasing. And if you look at this little area here, that's exactly what's happening. There's no increase in distance. The person hasn't travelled any further, but time is still ticking away. So what that means is they've stayed in the same spot for a number of seconds. So here it starts the rest here at 20 seconds and finishes at about 40 seconds. So we can just write that this person had a rest between 20 and 40 seconds. So this person had a 20-second rest, okay? So that's what rests look like on distance-time graphs. It's perfectly horizontal lines. All right, fantastic. Let's go on to our next question. Okay, so the next question I want to go through is, after how many minutes did the person return to the start? So this is exactly what I said earlier on, that when it says after how many minutes or at what time or whatever, it's asking you to find a corresponding x value. So as I said, for this journey, the person started off here, so started off there and travelled in one direction up here to 40 metres, travelled for 40 metres in this direction, and then came back to the start. So when you can see here that at this point, the x-coordinate is 100, so that means after 100 seconds, but the y-coordinate, the distance, is 0. That doesn't mean he hasn't travelled any metres at all. What it means is that this person has returned to their start. They're 0 metres from where they started. And that's what all of these actually mean. So this says distance in metres, but actually means how far they've travelled from the start. Or in other words, how far they are at any given time from the start. So the answer to this is easy. He's returned after 100 seconds. Okay, the final question I'm going through is a little bit more tricky. That's just for people who want a bit more of an advanced go of this. So you can skip forward about 30 seconds or so if you are not interested. So the extension question is, when is the speed the greatest? So these graphs are good for determining speed because they show you the distance and the time. Distance over speed equals time. So what you can see here is that from the 40th to the 60th second, this person travelled from 10 metres to 40 metres. So he actually travelled 30 metres in 10 seconds. From this point here, again, to this point here, he's travelled down 40 metres, but in 40 seconds, okay? So, if you look at this area here that I'm circling, sorry, the circle's not coming out the way I want, the speed here is greatest because he has travelled quite a long distance in a very short space of time. So between 40 and 60 seconds, he's actually travelled at a constant speed, and that's where it's the greatest. How do you know? Just by looking at it? You look at the slope of the line. The steeper the line, the higher the gradient, which means the greater the speed in this context. Okay, now we're going to go through drawing your own graphs. Okay, so this is the kind of question you need to be able to do. Draw the graph of the journey of a car that travelled 100 kilometres in 5 hours, 20 kilometres in its first hour, and had a 1 hour rest after the first hour. So first thing we do is we draw up axes like I have here for you. Okay, so we make sure we label them. So remember, the y-axis is the vertical axis and the x-axis is the horizontal. Now this is the time. Now it's going to be, I'm going to put h for hours because that's the information that we got was in hours. And this will be distance. So the y-axis will be dist for distance, and because it's talking about kilometres, I'm just going to put in brackets km. Okay, after we've done that, let's label our axis. So I have to go up to 100 kilometres for distance, and I've got 1, 2, sorry, I should, at least we've got 1, 2, 3, 4, 5 divisions. So I'm going to make each of these 20. Okay, so each of these represents 20 kilometres, so that the whole thing represents 100 kilometres. Okay, so I just moved things around there. So we're talking about distance in kilometres, so I've put the divisions on the y-axis. Now I have to do the same for the x-axis, which is time. So I have to go up to, and 5 hours is the limit there. So I'm going to make each of these divisions here, 1, 2, 3, 4, 5, 1 hour. So 1, 2, 3, 4, 5. Okay, nice and easy. Now what you might notice is I'm only using this positive quadrant over here. This one here. Only the positive x and y values, because I'm not going to have a negative distance or a negative time. So I'm only concentrating on this area here. Okay, now I've done all that, I'm going to actually draw my graph. Okay, so I'll get out red. Okay, so 20 kilometres in first hour. So from 0, which is here, to my first hour, which is here, I've travelled 20 kilometres. So I just draw a line between those 2 points. Nice and easy. I'm sure yours will be nice and ruled up. Okay, 1 hour rest after the first hour. So my second division, as I said, was 2 hours. So a 1 hour rest is horizontal. I'm not going any distance, so y doesn't increase. So that's what it looked like for that. Now the only other information I have is that I've ended up at 100 kilometres after 5 hours. So what I do is I go to 5 hours, which is here, I go to 100 kilometres, which is here, put a nice dot, and then join up the line. Okay, easy as that. I now have a line that's represented the journey. Okay, I don't put arrows on the end of this because it isn't a line that goes on forever. So the graph to your left is a representation of the journey to the right. Okay, that's all you have to know for today. So if you have any questions, please let me know. You can watch the video again. Other than that, this has been the luckiest maths teacher in the world. Have a wonderful day.